So, last video, we talked about ionic bonding and the basics of electrolysis. Now we'll get into more details about electrolysis. These are voltages and the conductivity of certain materials. First of all, voltages. Say we have water. I'm just going to place 4 water molecules here. And each one has 2 hydrogens for 8 total, and each one has 1 oxygen for 4 oxygens total. And then they all have single bonds to each other. Now, voltages need to be controlled for optimal electrolysis. The lowest voltage that can be applied to water to start electrolysis is 1.32 volts. However, if you have 1.32 volts, you also need to have infrared photons coming in as heat to actually split the molecule into hydrogen and oxygen, its individual parts. So, the limit that doesn't need heat, well, the lower limit, of course, is 1.5 volts. So, if you take water, put a bunch of Epsom salt in it, and drop a battery in it, you'll start seeing gas bubbles coming through. So, I gotta show you an effect. Let's put 0.1 volts through these molecules. Nothing happens. 1.2. Nothing happens. 1.5. And the molecules start splitting apart into hydrogen and oxygen. However, there's a catch to this process. You remember in the last video where I mentioned Epsom salt or magnesium sulfate, and I also mentioned it now. It turns out that this is necessary to make the water conductive. Another way you can do this is by taking water. Let's imagine we have 2 molecules for simplicity here. 4 hydrogen total, 2 oxygen total. Sorry, I know they're a bit sloppy. And let's imagine we have CO2. And when you get CO2, it becomes carbonic acid. And then the carbonic acid breaks apart into hydrogen and oxygen. So all of the stuff floats away. And then above, between the anode and the cathode, you see a bunch of stuff coming here. You get double the hydrogen as you get oxygen. So, well, I actually got that mixed up. The cathode produces hydrogen and the anode produces oxygen, which is kind of confusing. So, different chemicals have different voltages needed to kickstart electrolysis. Some of them might be very basic. For example, the electrolysis of aqueous NaCl. No, not aqueous, molten NaCl. You may just imagine you just plug a 9-volt F1.5 volt battery into there and it'll work, but not really. It needs higher voltages because NaCl has a different makeup than H2O. I mean, if I just draw them both here, you can already see how different they are. This has no resemblance to this. Ignore the fact that I just made brine. Now, the thing that's really interesting is what happens at the end. If you've ever done electrolysis at home with brine or with water mixed with Epsom salt, you'll notice by the end the solution becomes very oily and yellow. This is because of the subcompartments. Say if you're using brine, or maybe it may be better to just say aqueous NaCl. Let's build that up here. It turns out that that brine actually does something weird. With electrolysis, you chlorine is produced. So I'll get some more chloride to show the little crystal of NaCl. Remember, Na plus, Cl minus. What happens is that the chlorine gas separates and floats out of the mixture, and then something weird happens. And the sodium is actually going to react with the water. And what's going to happen is it's gonna send its electron to the oxygen and turning it into hydroxide, and they're gonna ionically bond. Same thing happens with the other sodium. The sodium just goes over and transfers its electron to the oxygen, and then the oxygen can't support its extra hydrogen anymore, and those hydrogens that are just floating around recombine into hydrogen gas. However, the thing happens here, once the hydrogen and the chlorine float away, you have D's, sodium hydroxide, and that's what creates the yellow liquid. For magnesium sulfate, aka Epsom salt, it's a bit harder to know, but just note that the yellow solution inside is some alkaline solution. That means it has a blue color when dipped in litmus or red cabbage indicator instead of a red one. If you're doing it with table salt, which is not recommended because of the potential to produce chlorine gas, which you don't want, so I'm just gonna get this and get out of my environment. Delete. You really are not going to want to touch the yellow liquid left over because, as I said earlier, it's going to produce sodium hydroxide, and that is just going to give you chemical burns, which is not great. So there you have it. That's electrolysis and ionic bonding explained. Bye!